So, basically, who am I and why I'm talking about this? My name is Reem. I'm a CTO at URAL Telekom company. Previously, I worked for Faladin application with 14 million mobile users. Previously, I also worked developing air traffic control systems, mobile device management system for 15 million devices, and a National Space Research Center in Turkey. I'm also underwater photographer. I like shooting fish and models under the water, under the sea. Yeah. So, our company, URAL Telekom, is developing secure communication software, also software refactoring for testability, that's about legacy systems, also software performance optimization. Objectives of our today's talk are briefly fault-tolerant system design, robust software design, robust software development. These are different parts because one is the whole system design, and the system should work, detect the fault, and still work as expected. And robust coding is more with the code itself, how the code should be developed in order to be robust, not to break. Robust, the difference is robust software should detect the error and display some notification. But fault tolerant should not only detect, but should continue working somehow. That's the most difficult part. And I will also present some tools and techniques how to achieve that 99% reliability. So what are the typical problems your application, your API, your web service, or web application is facing? Can I hear some examples, please? Cool. Okay. What else? Great. Invalid input is a reason, but how do we see from the user perspective? How do we experience that? Crashes. Yeah. So basically, yeah, you're right. You do something and it's not doing the thing as expected. So basically, unresponsive, crashing, some invalid or missing data, inconsistent data, or error messages. Like examples, of course, you click the button and nothing happens. Or the whole application is unresponsive. You can do anything. Just it's waiting for something. Or inconsistent data. For example, you go to one screen and at one screen you see you have 10 credits. You go to a different screen and you see you have 0 credits. That's annoying. So typical options for this is centralized management. You manage the credits or ask for the credits from the single source. Not every page is asking server for my credits or any information, but using a single class for managing that data. And error messages, sometimes you've seen that you go to a website and it shows an error. Then again it shows an error and you can't do anything just because of errors. So you need to separate. Are these errors critical or are they just optional, informational errors? For example, I couldn't get advertisement information. Is that critical? Should I notify the user? No. I should just keep it silently. Okay, no ads, no ads. Okay, no problem. But what if that's critical information, like I can't log in or the server connection failed? Okay, I displayed that once. Should I show it every minute or every second? No. You can be more user-friendly for that. For example, notify user and continue working at the background. The app should still be responsive and try to do its work. And typical reliability problems are, for example, if the system is 95% error-free, that's okay, it works, but it's not that good because it loses you revenue, it loses you users. If you have 1 million users, it means like 50,000 users that are angry, that are unhappy, that are not using your application, so you can show less ads, less sales, less revenue. And if your application is 99% reliable, even that is not that good enough. If you have lots of users. For 1 million, that means 10,000 users, and 10,000 users means 10,000 angry messages all over internet. So not only adds not only less sales but bad reviews. Bad reviews means even less users in the future, less revenue. So in total, it loses you more than 1% in revenue. So for fault-tolerant system design, typically it's the system that's aware of the fault. It knows I have a fault, and it's still working after the fault. There are methods we'll describe in details later, and it is waiting for recovery, and it is able to recover and understand that, okay, I'm back, I can do everything, and it's working as expected. But it's difficult to achieve because software is so complex, so many different people are writing software, it changes all the time. So we are trying to apply formal methods used for electronics, for hardware, to software. Some of them are okay, but still there are some software principles that we need to use. So designing. First part is fault handling. Understand the fault and know that there is a fault, response, and develop some reliability models. For example, like fault handling. The first option is avoiding the fault. How can we avoid the fault, for example? Retrying? No, that's later. That's the it's other parts. Avoiding, this is the design phase. During design, we say, okay, for example, some developer comes and says, okay, we found some cool stuff like Elasticsearch. Let's add Elasticsearch, and it's going to be great. Okay, we add Elasticsearch, but that's another node that can fail. So what happens if that fails? Besides, I'm not talking about maintenance, setup, and everything. So it's your decision. Should I use Elasticsearch? Should I add another point that can fail? Or keep working without that? For example, or designing systems so that the fault can be avoided. For example, making a redundant system. Making a copy of database. If the database fails, what do? You switch to the copy database, to the slave database. Maybe you don't even notice that it switches to a different database. Again, techniques for detecting the fault, acting on that fault, and also techniques for masking redundancy. What you said, retrying, was actually a dynamic redundancy. For example, our web service failed, let's say, a profile service. I can't get my user profile, but I have a previous copy of that, maybe in local cache or in Redis cache on the server side or on my application side. I have a copy, I can continue using it, because if I don't change my profile, probably that didn't change by itself, right? So I can keep on using that. So that's a little bit not fresh, it's stale, but at least it's reliable. It's nothing like garbage, for example. And dynamic redundancy is retrying at the background. We are retrying, we are reconfiguring, trying to use different sources, trying to come up with some solution, like instead of welcome John, you can display something, dear user, or something that your application knows that this data is invalid and still is showing something to make sure that it's working. And so there are also other techniques like rolling back, putting some journaling, keeping safe last known good data so you can revert it back to it. So fault detection mainly consists of detecting what's gone wrong. For example, network problem. Okay, you can understand from exception or from some status that, okay, there's network problem. Okay, the web service is returning some silly output, some exception code, right? PHP warning. And your JSON parser can't parse that. So you understand, okay, there is some problem. You can add some checksums. You got the information from the server, but the checksum fails. Maybe someone is doing some nasty things, or the service is not correct, is not working correctly. So again, you detect that. For example, you got the bad user profile information. That it's not name and surname, but null. So we diagnosed that we have a problem with this service, understood that, and then we need to isolate that. For example, in each page of your application, you are displaying, welcome, dear sir, would you like to display welcome dear null, or you have null credits, or you have none credits, yeah? So it's not good, and it's inconsistent. So in order to prevent that, your system should be able to understand that the data is bad and prevent it from propagation. Isolate that bad data. For example, you have a local copy, and continue using local copy, but notify user. Okay, we are having trouble, but you can still go working, like Gmail application. If it doesn't connect, it shows, oops, we have a problem, but you can still open your emails, write new emails, and continue working. That's a good example of a fault-tolerant application. Then, reconfiguration part. For example, if you have a problem with database, then you can continue using your cache and notify other components that, okay, MySQL database is bad, we cannot use it. Don't spend your time trying to connect to MySQL. For example, connection timeout is 60 seconds. Okay, then on your web application, all requests will start collecting, waiting for timeout for 60 seconds. Then your web application crashes. Then you need to restart the application server. You need to restart everything. So you have to avoid cascading failure, because one failure can end up, one single increase in the latency can end up crashing everything. So then, if web application is unresponsive, if the service is unresponsive, then the application becomes unresponsive, and so on, and crash everything else. So, typical solution is restarting the server or anything. So, there are three types. Hot restart, you restart only the faulty module. For example, if you have microservices or some parts of application or some part of your network, you just restart that, and the rest is still working. The term of warm restart, you kind of restart the systems, but you still get the latest data. At least part of the data is there. You only miss part of the data. And cold restart means restarting the whole system and reloading all the data from the start. Also, when you repair the system, you should understand that, okay, MySQL is good, we can start using it again. And, for example, the service is working, we can continue getting data. And reliability models can be divided in serial and parallel. Serial means there is a serial. If one node fails, then all subsequent nodes are unreachable at that time. But the good thing is all nodes before that chain are reachable. So parallel reliability is you put many nodes, all critical nodes are at least duplicated. So if one fails, then at least there will be a copy that's available. Any question up to now? Is it, do you want to go into more details, or is it good? Fast, slow? Any feedback? Okay. So one important thing is all of these are design errors. All of these can be fixed during the design phase, or avoided, or at least, let's say avoided at design phase. For example, fault avoidance. One principle is no single point of failure. Okay, the database is your main point of failure, so make it two. Okay, or add something else. Add cache in front of it. Add HTTP cache. Add more. We will go into detail a little bit later. Then everything should be redundant, but running the same copy of the same software on the same server is kind of useless, because that software is buggy. It faced the same problem and it crashed. So how do you know the other copy doesn't crash? Because the conditions are same. If it's running on a different server, then things may be different a little bit. But basically, using different designs also help, like copy of MySQL and copy of Redis cache. One server is MySQL and Redis cache, so at least they are different, and probably they won't fail at the same time. At least you will be able to use some of them. So replicating the same design is useless. If you have something for backup, it should be also a different software. Detection. Okay, you understand that there is some network exception, network timeout. So nowadays, waiting for default 60 seconds timeout is meaningless, even on the websites. So you should try to reduce that, for example, a web server timeout or Ajax request timeout to 5 seconds, maybe 3 seconds. In modern world, that's, I think, understandable. Nobody will wait for 1 minute to finalize purchase. Okay, again, JSON parse errors, checksums, and isolating the error. Reconfiguration phase is you understand that one part is not working. For example, in your web application, orders module is not working, or the video stream is not working, but other parts should be working, right? So, and it would be good if you don't allow user to click video stream if you know that it's not working. So you notify whole system, say, okay, video service is unavailable temporarily, and then user, when he tries to click, tries to watch something, he will be displayed an information, we are experiencing problems, come back in 5 minutes, or we are retrying. Maybe give him a retry button for himself. So graceful degradation is you just disable part of your system so that it doesn't work and it doesn't annoy user. And user knows, okay, this part is not working, consider elevator. If there's a power outage, your elevator will go into a graceful degradation. It has a battery backup and go down to the closest floor and open the doors. Okay, and it works. You are not dying out there. You have some light, so and you are able to exit. So that's fault tolerant. So the same the same is valid for your application. Your application should also be like this. Okay, understand, it's not working, but at least go to some specific state and let the user know about this. And also, as I told this, if you don't prevent this, for example, if user profile service is not working and you don't disable requests to it, so then more users will be angry, they will be clicking, more requests coming to your application server, and your application server will crash. That crash will trigger another thing, then login service will crash. So all of them will cascade, there will be a cascading failure, all of them will crash at once. So instead of just simply restarting one server, you will have to restart all of your servers. Recovery part is when, in order to recover, you can implement transaction safety. You can use last known good data, for example, from cache, from your memory, from somewhere that you know this data was good. I can't use the bad data right now, but at least I can do this. If I'm placing order and it failed, okay, I'm saying I can roll back and go to payment page again. Say, please try again, and not just show some nasty server error page. For the same is for payments. For example, the payment button crashes the service. Okay, the service crashes, you understand that, but the user wants to pay, he clicks again and again and again. Maybe something happened in the network. So the transaction is okay, the payment is okay, but your application doesn't know that. Maybe there is some PHP warning or anything, or JSON format is bad, but user wants to pay, he clicks again and again. So in order to prevent duplicate payments, you can use transaction IDs. Before making a payment, you just send some transaction ID, maybe order ID. So is this order ID paid or not? So you prevent duplicate payments. For transaction safety, showing retry buttons. And then when the network is back, when the server is back, you need to understand that. Of course, there is some background service checks, background maybe network. You can listen to network changes and understand, okay, network is changed, maybe now it's reachable. Maybe now I can retry. And at the background, there should be some service retrying. And then notify, okay, we are done. Everything is working again. Sorry. So the design methodology for this is just list all modules in your application. What are there? Database, I don't know, media files, video files, web application server, streaming server, cache, your web application, maybe local application cache or storage. So identify all of the modules, list points of failure, what can fail, and what will you do when it fails. What is the backup plan? So you try to design a system where there's no single point of failure, and even if it fails, the system can continue working. One method for responsive application, I mean, that's still responding, is separating data from control from metadata. For example, if the video is not available, okay, the application should not be freezing because of that. Okay, the video is not available, but I can log in, I can log out, I can see my profile, maybe update my profile, but those simple queries should not be working on the same application server. The big amount of data, streaming, the media, the content, the products, they may be running on a different server, on a different application. So if that crashes, still other operations should be working. So here the technique is a little bit stale, a little bit slow. So either everything is using transaction safety, but it's a little bit slow, but that's real data, or it's a little bit stale, but it's from cache, but it's very fast. So later, the eventual consistency, in a few seconds, maybe you will see the the latest data, but it's okay for a user to see all data for a couple of seconds, maybe. So development, the application development is iterative. So fault tolerance is also iterative. You can release an update, and this may change everything. This may change your fault tolerance design. So after that change, you have to also revisit the fault tolerance, how this affected, or what is the latest system status, what's going on now, and reiterate it, and make sure that still the system is reliable. Now, this is the typical scenario. First, while you are developing and testing, your application has lots of failures. Then after testing is done, the application is good. Next release means new errors. Then there gets fixed. Then another update. So this is the basic application lifecycle. So again, why these crashes appear? Because the changes in the application resulted in some fault tolerance outage, or maybe the application is not fault tolerant, so user sees those errors. So, what are the sample application modules? For example, the web service, database, content, UI. Anything else that you want to add? Let's make a sample design. So, this is the application. This is like a mobile application or a web application. This is the web service, storage, and media files located somewhere. So, what are the points of failure? The database obviously is point of failure. Web service itself is point of failure. Maybe it's crashing and unresponsive. Media files may be unreachable, lost. Maybe the path is incorrect. Then network, and of course the application itself. So what can we do to improve this? We can add local store, local cache, either the web application or mobile application. It can cache the media files, the profile information, any information that they got, they can store locally just in case. Just if anything goes wrong, still the application will continue working, but at the background tries to get that information. Again, if we add cache, we can cover for this SQL server. For example, if this connection or if the SQL database crashes, then you can get the information from cache. then another. So this is a typical situation. So the media files are not going through your web server, so you are separating that data from commands, from the metadata. Again, you are using some HTTP cache, CDN to distribute that data. So now there are lots of systems, lots of parts that are redundant, that can protect you. So what could go wrong here? Let's speak of scenarios. For example, if there's something wrong with the database, what can we do? What your application should do? Let's say where I'm speaking about this web service at this time. Okay. Yes, right. So you get the data from cache. You can continue using cache, but you know that this connection is wrong, is not working. You can notify all systems here, at least in your server. You can reconfigure. You can update a setting and say, MySQL bad. Maybe you have some logging server here, CloudWatch, Logly, or whatever you're using. Maybe that server is bad. Okay, you also update. This logging service is bad. Don't use. Just disable it from configuration. Again, cache is bad. Don't use cache. Okay, everything goes directly to the database. Payment API is broken. Okay, don't use payment. Reconfigure. Notify everyone. Notify even this web application that payment is bad. And sorry, we cannot accept payments at this time. Or we cannot accept PayPal payments at this time. We cannot use credit card, but PayPal is okay. So, again, for each of these items you can do, okay, web service is not working. What else? Here, HTTP cache may help for part of your, for example, web page will be loading, but you cannot log in. Or if you have a separate server for that, you can continue logging in if you have a separate server. And if everything is down, if you are in a subway, if you don't have any internet, still you have lots of data on your local application that you can continue working. So here, this reconfiguration prevents cascading failure. If the database is bad, okay, this doesn't have to wait for 60 seconds. If you have like 1,000 requests, each waiting for 1 minute, then your web server will probably crash quickly. So that part was related to the system design and formal methodologies. The rest is more related to coding and the more low-level design. Any questions up to now? Great. So, robust application is the one that can detect the errors, display that that know that, okay, I have an error. So mostly the problem with modern applications is they don't detect an error. For example, some invalid user input or null input. They don't validate, they just crash. And they don't log it, so no one knows what happened. No one knows if any error occurred. So, robust system should be able to detect failure and indicate it. Two things. Reliability for that can be accomplished using redundancy. Yes, we can put two servers, but if that's design fault, if that's in software, you can make as many copies as you can, but if there's no null pointer checking or value validation, then you will continue getting errors. So Neil's story says that software faults are all design faults that could be prevented at the beginning before starting to coding or during the coding phase. So the faults are mainly from software specification. Maybe there is some wrong understanding in the software specification. The developers may understand it wrong. The analysts may understand it wrong. Or maybe different departments, different modules don't know what the other is doing. Again, design error, like if every module is doing its own work and they are keep crashing each other. Developer errors, of course, no need to say, and unexpected conditions. In code, of course, what's the difference between an experienced developer and a young developer? In experienced developers' code, you can see lots of if, else, what, if, null, all kinds of checks. Yes, the program becomes 10 times more, but it's also 10 times more reliable. So handling unexpected conditions is the main idea for robust development. For example, here we have a simple code. Can everyone read? Or those who are interested? So basically, we say if payment type is PayPal, then go to PayPal service, make payment, then update orders table and update users, update order count. So what's wrong with this? Let's give me at least 5 problems. Okay, 1. Sorry? Yes, okay. Validation. PayPal can fail, right? 3. Yes? SQL injection. Let's say we have handled that before. I mean, no, this is a function. So by the time order ID gets here, I hope it was handled. So it's not responsibility of this method. But okay, good. Yeah, MySQL query can fail. Yeah, we got 5. Any ideas more? Yes, we will discuss that in the next slide, but yes, good idea. If the PayPal fails, then you have to do something about that, right? Not just say, okay, update, and I'm fine. So, also, let's repeat one by one. First, here's an if, and there's no else. What if I made not SQL injection, some URL, I played with URL, and saying payment type is RIM. And it says, okay, order is shipped. What if PayPal fails? We need to do something about that. What if query fails? We need to do something about that. And we also update user order count. That's not that much important, but the issue here is, that's design issue. So here we are updating orders and updating users. I don't know what is this module, probably some purchase module or payment module, but we are directly poking orders, and who knows who else is poking orders table, updating. Maybe, for example, this status, I'm saying status is paid, which is string. What if tomorrow I just hit keyboard by accident and there's a typo? It ends up in paydo, and all your pages, in none of your pages you can see this order, because select where status is paid, select where status is none or new. It doesn't select. SQL statement doesn't find this order. So the state machine is broken. The order is somewhere else. Hopefully you can put some view all orders so you can find that order. Otherwise it's lost somewhere. Again, if this crashes, and I'm updating the user, maybe, I don't know what's going on, maybe user table is being updated. The biggest problem is, we will go over it, that everyone is doing its own work, but on the other modules field. This module should not be updating orders or the users by itself. Its responsibility is just payment. Okay. Next, the biggest solution is separating of concerns. We need to split code by the modules, and the modules should not be accessing each other's data directly. Accessing or modifying, even modifying, that's the biggest problem. Today, you hired a new developer, he came, and he's updating the orders table by himself. And you don't know what he's doing. And you can lose that order, as I mentioned. You don't see customer complaints. My order is lost. Where is it? Or where is my shipment? I don't see any tracking information. So just because someone else modified it, and you don't know which kind of status he's using. Maybe he added some new status, like checking or fraud checking, whatever, and you don't know. No direct data modification. You need to update data through a dedicated repository or service. Update user information through user repository, through user service. Update order through order service. What's the difference between repository and service? Why, which one we should use? I order beer to the one who first answers this correctly. Correct. So repository is for storage only. No logic. All logic is here, validation. For example, I'm trying to update the order. I'm saying, okay, order paid. Okay, but as I told, some young developer came and he doesn't know the system. He's updating the order status. Who is validating it? The order service. The order service should check, okay, is it paid? Is it okay? Is it not empty? What's the status? Can we ship? Is it in stock? All kinds of business logic goes into the service. Your beer is on me. So, and repository also should be accessed only through service. No one accesses repository directly because it doesn't have the business logic. So here, put logic in the service and cover it with unit tests. All SQLs, whatever, or you can write it in plain files. It's up to you. All that kind of stuff goes into repository, and you don't need to test it because it's the connection with the real world, with the real APIs. This can be totally mockable. You mock repository and test the service with unit tests. Any questions? Cool. So, a little bit improved example. Here we converted this to switch because there may be many payment types, and we don't want to say if else, if else, if else, because that also sucks. And okay, we said case, constant PayPal, payment. If payment service is okay, then return system error. If it's not okay, return system error. Here, of course, it's up to you. Either you can return system error or throw an exception. It's up to you, but the basic idea is you are checking the status. Then, okay, order service, you are paying, you marking this order as paid, and it will also do something on its side. Shipment service, ship the order. Okay, so what's wrong here? Oh, cool, we even add a default. If it is unknown or unexpected payment type, we are returning error. What's wrong with this? Yes. So, next step. What do we do here? For example, if payment is okay but order is not, we couldn't update the order. What do we do here? This is exactly what the fault-tolerant, robust application should be thinking of. Either we can leave it in some inconsistent state or make up some watchdog software running in the background trying to find orphaned orders that are paid but not updated. Again, for shipment, here, again, we couldn't ship it. What happens here? We need to think, okay, paid, updated, but we couldn't ship. Again, the order is there on the warehouse waiting for months, and it's lost. So here, again, it's up to you. You need to think, what should you do here? So what can we do here? Any ideas? Okay, so what do we do? Oh, throw different errors. What do we do with those errors? Okay, good. We can handle them separately. We can handle them. It's up to you. So exception handling is a good topic. Is a very broad topic. So here you can return or throw exception, different type of exception, and the code calling it could think what to do. So, for example, if this is simple service, simple payment service, then it's not your concern. Okay, I tried. Okay, I give up. but you should do, the master should be thinking what to do next. So this is solved. The invalid inconsistent state is solved by state machine. State machine should be managed by a single class. For example, the order is new, order service. Okay, new order. It transitions to ready state. It transitions to shipping state. Transitions to completed or returned. From here, it can go to refund, whatever, or negotiation. So, but it should be done through a single class, through a single service. And it's easy to cover it with unit tests and to make a setup. For example, if there is some specific case, PayPal failed, but shipment, PayPal okay, but shipment failed. So what do we do? That's exactly what you can try with the state machine. It's easy to set up that using unit tests. You say just status, okay, shipped, not shipping, payment is okay, blah, blah, and run the test. Only 3 lines of code. But if you do it in real life, you have to update the database if you have direct database access. Otherwise, you have to simulate that real life situation, simulate that error, shipment failure, etc. Exception handling. Exception here is more like edge case detection, not software exceptions that we throw around, just edge cases. Exception is what we don't know and we didn't predict. For example, unknown, invalid input, null input, connection problem, anything else. So if you handle all those unknown, unpredicted situations, this will improve your fault tolerance. You can understand, okay, I got it. I have the problem here, and I know what to do this. I thought, what should I do with it? It's not just a good path, a safe path that's okay, but I'm also thinking about the exceptions. What happens if something goes wrong? And when you are throwing exceptions, you decide where to catch those exceptions and who should take care of them. So software fault results in some internal state, but you should understand it. You should display it to the user, and you should notify other systems so they should know that there's an error. Error detection can be memory-based. For example, you received some new profile data, you compare it with the previous and say, oh, look, in 5 minutes he couldn't grow older or something, just an example. Or if you are getting stock information, you can do some logic to understand what happened, compare it with the previous information. Or memoryless. You receive the data from JSON request, IAX request, you receive the JSON data and validate it right there. If the checksum is okay, if the data, all the fields are available, and you say, no, that's not invalid. And you don't even copy it to the memory. Recovery methods are backward recovery, where you go to last known good state. You got the data, it's bad, go back. You say, okay, this I know that this was good. I continue displaying it for a while and say connecting, but the data is there. And forward recovery is for more complex systems. You can recalculate it or retry and try to get that information back. Also, use some error compensation mechanisms to put the data in the correct state. And use all kinds of fault masking. So you can go into degraded state, say, okay, we have a problem, but we are trying, we are still working on it. And there are external consistency checks. If the exact result is difficult to compute by yourself, you can add some other external software, maybe watchdog software, that's checking, is it okay, is it okay, is it responsive, is it hanging? Or, as some people do, probably you've seen that, for example, if the application is working for 1 hour, then due to memory leaks, it hangs, it crashes. So you develop a watchdog software that will simply restart that, or that application will restart itself after a while. Okay, that's a workaround. You don't know the solution, but that works. or add some periodic checkpoints. Okay, you say 5 minutes ago I was good, now I'm good, and then you can go back to the previous state. But you can store it somewhere in external place. Internal is using checksums, validating all kinds of data in the memory or received data, and safety net. For example, when I was developing a traffic control application, we were shuffling around the planes on the screen. Okay, plane is here, plane is there, start engine, taxi. And what if, due to some software exception, I pull the plane and it doesn't end up on the screen? It's lost, it's orphaned somewhere. So what then? Okay, the plane is lost and I don't know where to find it. So here, okay, you need to unit test that part very toughly, but still there should be a safety net. For example, I moved it here, but it's not there after I dropped. So after you drop, check, is it there actually? Or maybe it's somewhere orphaned. Maybe you can run a watchdog software at the background to find any orphaned planes that are not in the UI, just as an example. So internal consistency checking is for the software development. For example, you have configuration. Use this, timeout is 15 seconds, the minimum user age is like 18, and everything else, but you have different configurations in different files. Or you are making configuration for each country, or for each language you are keeping a different configuration, right? So, what if you forget to update one language? You added some field, but forgot to update it in some different configuration file. Then there will be null and the app will crash. You didn't code that part. I'm sure that you would handle that null value. You would check that, but someone else didn't check. So that will crash. Because the problem with the application is you update something and something else crashes that you didn't even think about. So for consistent configuration, you can merge them. You try to keep them at the single structure so that if you update something, you don't have a chance to forget. You have to update it. Or add some integrity assertions. Like for each language or for each country, check if all fields are same for all structures. And you updated it, then run the application. I hope you can halt the application. Just display country configuration for Norway is invalid. Check the configuration file, right? Hopefully you test it, tester tests it. So before deploying it, someone should notice it, right? I hope. So, or you can send a friendly warning, like log a warning, or display some message that there's some configuration problem, if someone is watching your logs. Again, if there are lookup tables, some configuration for lookup tables for mapping, I don't know, for example, converting one format to another, and also you can add some checksums to that table. If I add a new row, and the checksum should validate it somehow, either during unit testing or during startup of the application. Again, you should show the warning to the user. And some kind of reminders. All of these are to prevent someone to forget, to prevent you at the first place from forgetting something. Or tomorrow another person is coming, new developer came, he knows this part but forgot or didn't know something about the other part. And domain isolation. So basically, if you have some module, the other developers shouldn't know much about that module. Just use it with some convenience methods. Simple application. We have a football game class, let's say, and you have two convenience methods, pass and shoot. You can write such a generic method like action, and you get type right. That would be beautiful and less code. But why use this and make this private. Exactly. You cannot pass invalid value. Since this is PHP, you cannot ensure that I'm passing this. Someone came and maybe you came and passing 3. What's type 3? Maybe this will crash your application, end up in inconsistent state, or lose the ball. You are playing football and where's the ball? So, and another thing is, I don't have to know what are these. I don't have to know the constants, the other detailed information about this. Just pass. Okay. Everything else. And yes, this is using the internal method, but it's easy to use. And I don't need to publish that. What if I change this later? What if the logic changes? I should keep the logic inside my domain, inside this football game class, inside the order service class. So if, for example, as I told, if we add some other status in the state machine, the order is processed, but is in this, how was it? When someone complains, in the complaining status, okay? So we added that status, or added escalated to management state. And everyone should know, okay, it is passing from payment status to escalation status. Everyone should be notified that there's new status escalation. No, hide that. Payment okay, then your application, your class, your service should decide what is the next status. Not half of the class, half of other developers from other departments. They don't have to know. Just make it easy. Also, I was saying yesterday, the more easier your class is, your API is, the easier it will get adopted. For example, there's an old API and you develop newer one. Yours is great. It's beautiful. But you don't have examples, or it's difficult to use. Like you have to read how to use it. There are no examples. Then nobody will use your API. Everyone will continue using the old API. So if you provide some examples and make it easy, it will get used. Example. What's wrong with this? I'm saying cache, invalidate, delete this item from cache. This is my user prefix, just as an example. And so I'm building my key here. Okay, Redis cache is very generic, good for you. But, for example, how maybe tomorrow I will add a different prefix here. Or maybe some department will decide to add a prefix for session and creates his own prefix, which collides with this. That's a big problem. So instead of that, which one is more easy to use? Which is more managed? This one is more managed because it's the user cache it should be. Both of them are user cache, or maybe no. This is user cache, a specific class that's responsible for user caching. This one is easy to use. Again, reading from cache. To read this, I need to copy this whole code everywhere. Instead, why not just get user? That's much simpler and less errors, less collision. This is just an example. You can extrapolate it to any other domain. How about time? So we are almost out of time. So let's, I think we are almost over. So the systems can wear out with time due to memory leaks, etc. And restarting usually helps, yes. So that's one method. I'm saying the formal methods from electronics design. So this is interesting. Exception failures, unhandled exceptions, unhandled edge cases. This is not only software exceptions, but edge cases mainly, are causing 60% of all system crashes. This is an official number, official statistic. And 50% of security vulnerabilities. The SQL injection. Yeah, SQL injection. Why? Because you didn't think that someone will add drop table there. Okay, so to handle edge cases, these are the best methods for handling the edge cases. Code review. During code review, you can set up some guidelines to check if that code is verifying all the edge cases. Also, you can verify that using unit tests, trying to input invalid data or some corner cases, and integration tests, of course. So let's make a sample, very simple code review checklist. Like, all corner cases are handled. When you are reviewing the code, you see, okay, there is no else. Well, you say if, but what is else? Or you are not validating the input. All numbers should be constants. What if we change it? Or it's not readable? No hard-coded numbers or strings. All errors are logged and warning displayed to the user or to administrator, whatever. And parameters and input is validated. So the code review checklist should be small enough so you remember everything and you don't spend too much time on it. But this will prevent lots of problems. So, so much for the coding. Any questions about that part? Cool. So, tools. You can achieve 99% reliability using proper tooling. For PHP, for example, if you enforce type checking in PHP, you can actually handle 99% of all errors that PHP has, right? So, or same for JavaScript. If you use some tools for JavaScript type checking, again, you are a lot safer. So you can use tools. There are tools and techniques like reusing proven techniques and components, quality assurance, testing, making it simple. The simpler is design, the better, the less items will fail. As I told, if you want to add a new server, you can think, oh, that's a new point of failure. Why should I do this? Or maybe just make it simpler. Okay, not fancy, but fault tolerant. So you can use analysis tools and good development environment, both for PHP and JavaScript. This helps a lot. So proven techniques, proven libraries, frameworks, but use with caution because proven means old. So if you typically, yes, but if 5 years ago it was very robust, but what if you use it now? Probably everything has changed, so maybe you can't use it now. So it's up to you. You have to check it or find new proven systems or prove you by yourself. I told this. Oh, sorry. Small question. These are the techniques, and how do you think, which one is the best for catching errors? No more beer for you. Okay, what is the best? Integration test. Who else? Code review. Good. But who else? What else? Okay, so this is the answer. Code review actually can prevent 60% of errors before testing. Before QA department starts checking, sorry, I will rephrase. The code review could fix 60% of all errors that were caught by testers. This is official study by Dell. They started code reviewing, and they found that number of errors that their testers started catching reduced dramatically. So, and these are the others. Yeah, integration tests are the second best. Good. So there are tools for type safety, thread safety, security, finding edge cases, finding memory leaks, and code coverage. These tools are Psalm, SonarQube, PHP Stan, JS Hint, code linters, and development environment warnings. So most of us have to deal with legacy code, right, which has lots of warnings, but it's important to look at them. Okay, there are hundreds of warnings collected, but if you're starting a new class, at least you should hope you should look at those warnings. These are actually, this is doing the what that does, but for free. It says, okay, look, there's no default, no type checking, no initialization, wrong type, expecting int but passing string. This ID is telling that you for free. Okay, thank you very much. Thanks for coming and participation. Thanks.